Hi, RST-130. So, assignment number 5 um, is going to require you to get familiar with a few new commands, all having to deal with this new kind of object called the graph in Mathematica, which is similar to a list. Just like you can do all kinds of things with lists, you can do all kinds of things with graphs, and that's basically what we're going to learn about today. So, but before I do that, I'm going to show you some of the new files that I have developed for you that are going to help you complete the assignment number 5 and that are also going to help you quite a bit on the projects that you're going to be doing, or at least some of you are going to be doing. So what I want to do is show you this new, um, this new, here's the folder that I've shared with you. And what you want to do is you want to go to From Muslim Scholars website, scroll down to the graphs of isnads, and you will see a whole bunch of folders, 23 folders in all. And I'm going to go through, you're not going to use all of them, you're going to use some of them, but I'm going to talk about, what exactly are the types of files, what types of files are these things, what kinds of information are found in them. And it's going to be very helpful for you to do the assignment and for you to ultimately come up with a research question and pursue a research project. So let's get started with our Mathematica project. And let's boot up Mathematica. There it is. I want to do a new document and let's make this bigger. And I'm going to save it in the Graphs of Isnads folder because all of the information that I want to get is going to be from that folder. So and I want to set my directory to my notebook directory where and there it is. And I want to import in some information. Well, let me import in all of the isnads, the CSV file that contains all of the isnads, just to kind of give you a sense of what kind of information is in that file. So hopefully I've made this big enough so that it appears pretty big in your videos. Let me maybe make it even bigger. Let's see that 200%. Hopefully you'll be able to watch this. So import that, and the file I want to import, the CSV that I want to import, is this thing right here, 6 books, all isnads. So all of the isnads and all of the 6 books are contained in this one file, right? So when I do that, it imports in a bunch of stuff, 43,000 some odd hadiths with their isnad information only, right? So 43,387, and let's take a look at what's in each row. So if we do isnads 1, what we will quickly see is that the first element, this number 1, is the unique hadith number that we gave it. The second element is a 0, which means that if there is a hadith that has more than one isnad to it, that number will change. So the second isnad will be given the number 1, a third isnad will be given a number 2. And then these numbers right here are the IDs in order of the narrators included in the isnads for hadith number 1. Uh, One of the things that you will need to do in order to interact with this material is to expression this, because I think when it's imported in, it loses the the numerical quality of the third element. This 3 to 30418, it doesn't read it as that. So for instance, if I do, it'll give me a 1, which is what I expected. And if I do a 1, 2, it'll give me a 0, which is what I expected. If I do a 1, 2, 1, 3, it'll give me that, which is what I expected. But if I do a 1, 3, 1, it should give me just that number 3, and I'm going to get that error message. Whenever I get that error message, usually that means that for whatever reason, Mathematica is not reading, when it imports this information into that variable isnad, it's importing that third element as not consisting of numbers. And we need to change that very easily to expression, that entire thing. And now if I do, I'll get the 3. So this basically has, tens of thousands of isnads, all of them taken from all 6 books on the website that we're dealing with. And each of those numbers in that third element, the first number is the unique hadith ID hadith number, and the third element is the list of narrators in chronological order, 3 being the one closest to the Prophet, the companion, and that 30418 is the narrator that ostensibly narrated the information to Bukhari, for instance, and he's the one that wrote it down from 30418. Okay, so that's the type of information that is contained in this file. And the answer to the first question on the quiz, which is the single complete isnad that occurs most in each of the 6 books of hadith, you can actually answer the question using this file if you wanted to. One thing to note, and I will send an email out to you with this information, is basically any hadith number from 1 to the 1000s is Sahih Bukhari. 10,000 to 20,000 is Muslim. 20,000 to 30,000 is Sunan Abi Dawud. 30,000 to 40,000, I believe, is Tirmidhi. 40,000 to 50,000 is Nasa'i. 60,000 to 70,000 is Ibn Majah. But I will send that information out to you. All right, so we've done that. And let's import in a graph file for the first time. And let's call this Bukhari. And we'll import in the graph file for Bukhari. And let's do that. And Bukhari graph. So you can either import in the Bukhari graph file or the Bukhari graph.net file. Either one should be able to work. We'll just pick the first one. And I will hit enter, and it will take a long time. It will take a long time because there is actually a lot of information that it is gathering together and putting into my Bukhari variable. And the output of this action, you will see, is a very, very interesting picture. It's actually a picture. So it's working. And here's the result. It's this massive, massive graph of dots with arrows pointing to them. And what basically I have done is I have created a file, a graph file, where I've taken all of the narrators who narrated hadith to one another in Bukhari, and I have basically made them, each of the dots is a node, a narrator, and the arrow represents a student-teacher relationship. So this dot is the teacher, this dot is the student. Okay, and what it's done is it's taken all of the narrators, all of the 1,000 or so narrators in Bukhari, all of the 1,000 unique narrators in Bukhari, and it has graphed all of the teacher-student relationships, and it's displayed here. Now, obviously, this is quite difficult to read. And because there's no labels, you really can't tell like what is going on. So what we can do is we can add vertex labels. Let's see. And there it is with all of the vertices, which is the dots, the technical term for the dots. And what we can do is we can actually make this a little bit bigger. Maybe we can make it a little bit more readable. So here we have 11684 narrating 2047. So obviously this is not necessarily useful information to us because it is not possible for us to display 1,000 dots and the direction in which they narrated information to each other, who the students were, who the teachers were, in each of them, in one singular singular mass of things. Okay, so but what we can do is we can actually just take a subset of these, and they're called neighborhood graphs, and just graph like the relationships between Aisha and all of the people that she narrated to. We won't go there yet. But let's say that, okay, this variable Bukhari has all of this information, and I just wanted to know a very simple thing, and that is, who are all of the narrators that have narrated information in Bukhari? And there is a command to do that, and that command is called vertex list. So vertex list Bukhari basically says, give me a list of all the vertices, which is these dots, in my graph Bukhari. And there you go. These are all of the people, the unique IDs from number 3 all the way to 34118. Now let's say I wanted to know how many of these unique narrators are in Bukhari. Well, there's another command to do that. You can do it one of two ways. You can do length vertex list Bukhari 1368, or there is a command that gets it much more, vertex count Bukhari. There's 1,368 unique narrators that Bukhari has included in his book somewhere in the isnads. So that's really useful information. Now let's say we wanted to get a list of the directed edges, meaning the directed edges is the technical term. Oh, so that was the wrong command, but if you do edge list of Bukhari, you will get a list of all of the people, all of the relationships between any one of these two nodes. So we know that 3 at some point in time, somewhere, narrated to 11042, and apparently he or she did this 3 times, 4 times, 5 times, 6 times, 8, and then 11042 to 11213. And if we want to see how many teacher-student interactions, we can just do a length of edge list in Bukhari. And there's apparently 28,562 teacher-student relations between these 1,368 nodes. Okay, so, and what I've done is, if you look at the file, I have created graphs for each of the 6 books of Sunni hadith that are that are very important in Sunnism. There's the Muslim graph, there's the Abi Dawud graph, there's the Nasa'i graph, there's the Tirmidhi graph, there's an Ibn Majah graph, and then there is all 6 books combined in one big massive graph, one big massive set of nodes, set of vertices, and set of directed edges right there. You're going to have to rely on this information in these things, in these graphs, in order to answer the quiz question. Okay, so question number 3 asks you, which are the 10 most cited narrators in each of the 6 books? There are a couple of ways to do this. One is using the information that's in the Graph Bukhari, or the other is using the information that's in the Isnads file. And probably the easier way is the way that's in the Isnads file, which we uploaded, all the Isnads from the 6 books. But let me just show you how to do it from the graph, the Bukhari graph that we've uploaded. There's this there's a couple of commands. One is vertex list. If you do vertex list and you put in Bukhari, it will give you a list of all of the nodes, all of the vertices that populate the graph Bukhari. And there it is, right? So we see that. There is another command called vertex degree. And what the vertex degree will do is it will basically give you all of the connections that it will count how many connections each node, each vertex in the graph has, and it will output that to you. So if we do vertex list Bukhari, it'll give you a set of numbers, and basically this number 95 is the number of edges, the number of narrations, the number of relationships that 3 has to all of the other different nodes. And similarly, 16 is the number of relationships or edges that 11042 has, so on and so forth. Now, the problem with this is, okay, it's giving me a list of numbers. Now, I can very easily sort this list of numbers and get whatever is going to be the highest one. I mean, it seems like 1259 is going to be the highest one. I don't know. But then I'm not going to be able to tell which node has 1259 edges. And I'm not going to be able to answer the question, what are the 10 most cited narrators using this. So what we essentially have to do is create a new table, because these numbers correspond to the numbers on the vertex list. So basically, in order to have it input, to have like basically what I'll basically need is a list. Each row needs to contain two elements. One is the ID of the vertex, and the second element is the number of times that the number of edges that that vertex has with any number of other vertices, any another number of nodes. And the way to do that is to create a new table. And what we can do is create a table where basically we have we have a row, and each row has the identifying information of the vertex list and also the corresponding number of edges that it has. So for instance, if I did vertex list Bukhari, and then here's this funny way of doing things. If you do that, it will just give you the first number. Okay, so 3, who's Umar ibn al-Khattab, I believe. No. Yes, that is true. That's the ID, and then if I did vertex list, vertex degree of Bukhari, and I just wanted the first one, it'll give me 95, right? And if I did, another way you could do this is like how many for number 3, you can correct that. So the problem though is similarly, if you do 2 here, then you did 2 here, one 11042 is the ID. How many times does 11042 occur? 16. And then if you it gives you that. So basically what we would need to do is create this new table where we have X change numbers, iterate that 1 through the length of the vertex count, through the length of the number of vertices in Bukhari, and it will create this table. So 3 occurs 95 times, 11042 occurs 16 times. And obviously when you have an input like that, you can sort by count, and then you go down to the bottom. 11013 occurs 2,397 times, and that is your, these are, so you can kind of see 110, that's your most cited narrator, 20020 second most, 20001 third most, 10511 fourth most, 13,992. And for those of you that know a little bit about Islamic history, the lower numbers are the numbers that are associated with the companions. And it's very interesting that the narrators that occur the most in Bukhari's book are not the companions, are not specific companions, but pretty much people that belong to the 2nd, 3rd, 4th generation of narrators. So that's kind of interesting. So that's one way to solve this problem. Another way to solve this problem is through just the isnads, right? So when we've put all the isnads, all of the isnads for all 6 books are in this. And what we need to do, of course, is 2 steps. One is we need to get only the isnads for Bukhari if we want to know how many times does, how many times does a given narrator occur over and over again in the isnads. We only want to know Bukhari, we have to do that. And there's an easy way to do that. We know that all of the hadith numbers from 1 to about 7,000 and some number, basically 1 to 1,000, below 1,000, they belong to Bukhari, and then 10,000 to 20,000 belongs to Muslim, and so on and so forth. So that's kind of the logic of the hadith numbers, and we can use that to our advantage. So if we did, let's just B equals select from isnads where the first column is greater than 0 and less than 10,000, that will give us only the Bukhari. Oh, did something wrong. Oh, this needs to be 10,000, not 1,000. 10,000. That will give us all of the isnads of Bukhari only, right? So we've done that. Now what we need to do is we need to, we only care about the narrator's part, right? So for instance, we only care about this. We don't care about any of this information. So let's just say, let's just put all of that information into one bucket, right? So B, let's say B isnads equals okay. Now we probably want to flatten. We want to get rid of all the structures. So because we just want a straight count. Right? And then let's do a tally of, okay, there's a tally. We need to sort it. It's all unsorted right now. And sort by count, let's just use that. And 11013 is 1232. Okay. All right, so you kind of have, I mean, the numbers don't match exactly. And I think it may be because a lot of times these narrators in the isnads file will occur sometimes, not a lot of times. Just sometimes they will occur by themselves independently without necessarily having narrated to anyone, or Bukhari will just cite straight to that narrator as opposed to giving a full isnad. And that information is included in the isnads file as opposed to the Bukhari graphs file. It only has information when narrators are in some kind of relationship with some other narrator. So I think that's probably what's messing up the numbers. But regardless, that is the way. I mean, and then basically you can go in and you can do this. You can either use either method to go in and generate answers for question number 3. Actually, you can do that for question number 3 and question number 4. Question number 5 as well. Question number 6. Okay. So PageRank and betweenness centrality. Like, what are these things? So let's look at what Mathematica says about PageRank. So PageRank centrality. Well, it doesn't really explain what PageRank is, and there are basically, it's a mathematical way of trying to find out, given the bunch of nodes, like how many nodes do we have in Bukhari? 1,368. There's 1,368 nodes, and each of those nodes has a variety of different types of relationships and strengths of relationships and numbers of relationships to each other. That's kind of what makes up a network. So basically, when you have a network, a huge network, and you have all kinds of relationships between these nodes, you need some kind of way to be able to pick out which nodes, which vertices are the most important. And basically, part of social networking analysis is coming up with mathematical algorithms that you can put into a computer and have the computer calculate some way of identifying the most important nodes in a given network. And you can obviously, for marketers, using Twitter data or Facebook friends list, you can see why they would be very interested in trying to figure out who is the most influential person, because they're the ones we want to target all of our ads to. But when you're dealing with millions, maybe hundreds of millions of people, that's a very difficult task. You can't do that just manually. You have to automate it somehow, and then you have to develop effective ways to identify those vertices and those relationships. And there are a wide variety of such algorithms and computations that are available, and Mathematica has allowed us to do a bunch of them. So let's take a look at some of them. And what I'm going to have you do is do PageRank, use two of them, betweenness centrality and PageRank centrality. Let's take a look at, the types of, if you go to social network analysis, the document, you can kind of see the centrality and prestige. So there's all kinds of different measures through which you can identify which node, which vertex is the most central. So betweenness centrality calculates the fraction of the shortest path that passed through the actor, meaning it is all about trying to find out, like, if you want to traverse a network from one point to another, what's the most efficient way to do that? Which node, even though that node may not have a ton of edges, a ton of paths to other nodes, because of its relationship to the most important nodes, it ends up being really important for that reason. That's what betweenness centrality is supposed to measure, and PageRank centrality is supposed to basically measure that how important a node is in the context of its entire network. And I'll talk a little bit more about this in class on Wednesday, and I'll also give you guys the Wikipedia pages to read it over and see if you can understand it on your own. All right, so PageRank centrality is actually quite easy to do. All you do is PageRank centrality, you put your graph into there, and it will generate the scores, the PageRank scores, for all of the vertices. Now, we have the same problem here. The problem is, these are the PageRank scores of each vertex in the list of the order of the vertex list, right? So three's PageRank score is 0.00261,661. So obviously these numbers don't mean anything in absolute terms. It's only when you kind of compare which one's the highest, which one is the lowest, that you get a sense of how important each node is in the context of a given network. So we're going to have to do something very similar to what we did to find out about the nodes that have the most citations in a network. We're gonna have to create a table. But this time, what I'm going to do is instead of running a table, I'm going to use two commands, one called riffle and the other called partition. I'm going to use them together in order to create a list that will correlate the vertex list, each node, with its given PageRank score. And this is a really important command. You should probably take notes and highlight this because you are going to need to use this in order to answer the PageRank question and the betweenness question that I asked on the assignment. And basically what riffle does, so you can kind of see there are two central core elements at the very middle. Vertex list Bukhari and PageRank centrality Bukhari. Vertex list basically of Bukhari gives you the list of all the nodes in Bukhari, all the vertices, and the PageRank gives you the PageRank score of each node. And what I'm doing is I'm riffling them. And by riffling them, what it basically does is at first it gets the vertex list, then it gets the PageRank. And it alternates. And it ends up creating a massive list of double the of a bunch of elements. The the first element being vertex list, the node, and the second one being its PageRank score. And then what partition does is it takes this huge flat list and it partitions it into two. Every two, it creates a new sublist. So it's the exact opposite of flatten. It introduces hierarchy and structure into a flat list. And you can see that 3 is there, and 3 score, PageRank score is there. And if you scroll all the way down, you'll see all the scores for each of the individual vertices, nodes, narrators, and their respective PageRank scores. Now, obviously, what we need to do is we want to get the highest PageRank score. And in order to do that, we have to sort the list. And in order to sort the list, you just use the sort by command. And let's put page Bukhari back in there. And we want to sort it by which element? We want to sort it by the last element. We want the highest by the PageRank score. And it's going to sort it from lowest to highest. And if you scroll all the way down, we will finally know who does PageRank think is the most prominent narrator, prominent node in this network. And it is this 20020. It's this guy named Shu'ba ibn al-Hajjaj. You can go to Muslim Scholars Database and get his information, get his name, and you can do that for anyone that you look up. So we can also use a select statement, but this is a little bit easier. There he is, Shu'ba ibn al-Hajjaj. He was born around 82. He lived till 160, so he was kind of like the second, maybe the third to fourth generation away from the Prophet. And that's interesting. That person from that generation and not the companion is going to be the person that is the most central. I mean, it's interesting, but it's also a little bit, it meshes with our historical story where professional collection of hadith doesn't start happening until about 100 to 150 years after the Prophet's death. And when you have professional collectors, that's what you're going to do. Now what I'm doing is I'm going to show you a very easy way of getting the last 10 elements of any list. So you use the negative sign. So -10 through -1 will give you the last 10. The 10th from the last to the last. That's what the negative sign does. And it's a really helpful and useful shortcut way of getting to the very bottom of a list. But now let's do the exact same thing, except what we want to do is we want to calculate the betweenness centrality, which is a different type of score than PageRank. And what betweenness does is it doesn't, the betweenness score doesn't measure the number of what the probability is if you randomly start at anywhere in the network that you will end up. That's what PageRank does. End up on a given node. But let's before we do that, let's let's generate a list, a usable list of betweenness centrality scores that correlates to the actual node IDs. And there we go. We use the exact same type of command from last time. And scrolling down, and we want to get the last. We want to get the last 10. We want to sort these guys. So sort by. Let's sort this. We want to sort between Bukhari by the last element, and then it will sort it from lowest to highest. And we see 11013 has a really large betweenness centrality score. Makes sense. That guy's name is Zohri, and he is like probably the second generation of professional collector. Died in the year 124. So he's a little bit earlier than Shu'ba ibn al-Hajjaj. But it's interesting. It's interesting that these are the people that are seen as the most prominent narrators in the Hadith network. I mean, it's both interesting and it also kind of makes sense, given what we know historically about how the Hadith transmission network developed over time and when it started achieving a critical mass of activity. And the betweenness score, so let's get the last 10 betweenness scores. There we go. There's the last 10 betweenness scores. And let's see if we can view, comparatively speaking, these two betweenness scores, the betweenness scores and the PageRank scores, and see to what extent are these two algorithms, these two ways of calculating centrality, do they end up identifying similar, the same nodes, or do they end up identifying different nodes? So that's the column for the betweenness. Let's see if we can helpfully I think I know how to do this, to have two columns. I'm going to use the double and sign. There it is. So, so it seems like the bottom half of these two groups is quite similar, but then the top half is quite dissimilar. The PageRank identifies people not from the companions generation, but temporally further away from the Prophet's time, whereas betweenness seems to identify some companions at least as having having a quite prominent role in serving as a bridge, as very important bridges between different areas of the network. I mean, that's kind of what betweenness is trying to measure. And I think that the last thing that we need to do is, I believe I need to teach you about neighborhood graphs. How do you generate a neighborhood graphs? I mean, neighborhood graphs are important because if you just do Bukhari, right, it's going to give you 1,368 nodes worth of information, and it's going to take forever to generate that. And it's really not a useful way of divining information because it's too dense. We really can't make sense of it. So what neighborhood graphs does is it allows you to say, from Bukhari, I just want to know what the relationships of the nodes associated with a given vertex is. And let's see let's take, for example, the neighborhood graph of Ali ibn Abi Talib. And we compared him to Aisha, and his ID number was 5. And let's see how his neighborhood graph looks like, and what you will see is that it's actually much more readable, and it tells you some really interesting and neat information, and it depicts it visually. So let's take a look. There it is. There's that. Now that information is not. We need to label it. So let's add the vertex labels, and boom. There's 5 and 5. So it not only does it give you like who is 5 communicating with, who is 5 sending information to, and who is 5 getting information from, but also if there are relationships between the nodes that make up 5's neighborhood. So 31 is not only getting information from 5, but it is also passing it on to this 11045, for instance, who is then passing it out to 11013, who happens to be a very, very important. That's Zuhri, died in 124, and it was identified by, I believe, both PageRank and Betweenness as being very, very prominent, very, very important node in this vast network. So I believe you now have the ability to do all of your assignments, and the last questions, you don't necessarily have to use Mathematica. You might want to use it to depict visually the isnads, but you don't have to. You could draw it out on paper. What I'm looking for there is just qualitative analysis and application of the dating theories of Motzki versus Schacht, and just your own kind of intuitive sense of when and when basically those hadiths were transmitted, and whether you think the Prophet actually said them, and if so, on what basis you can make that argument. All right, bye.